Hi, we are the PowerTeam. We intend to tell the story of how Peter Parker turned into Spider-Man, replicating on stage the iconic bite which changed a young man's life, transforming him into a superhero. To tell this story, we resort to a button roll one which will impersonate the Spider-Man, and two spiders that we will talk next. Button roll 1 can be connected to a vast array of Arduino-compatible shields such as wireless communication, GPS, GPS-R and sensors to perform various tasks. We choose to use the infrared emitters in the obstacle detection circuit. They emit the light that will be reflected by the obstacles and line sensors. This sensor has the ability to identify the path to be followed from a line in black. The floor should be white. From the frequencies emitted by the sensor, it will continue to maintain its path, which in the case is the row. The working base is a TR-T500 reflective sensor, which is an infrared sensor which functions from the reflection of signals. To better convey our message, use the installation of LEDs in Spider-Man. The circuits developed are related to the use of LEDs. This was the circuit to turn Spider-Man LEDs on. For the Spider-Man, we proceeded to the installation of the LEDs divided into 3 blocks connected in series. In our particular case, we have chosen using an external power supply, a power bank goodies 10,000 mAh, micro USB. Because this was in the structure, 31 LEDs and the engineering battery would be sufficient to fill everything. Now let's talk about the spiders. In order to organize the 12 servants and following some note by Regis, we created a simplified protoboard that connects all the servants and provides them the energy. Again, we have some issues concerning the power supply. After some tryings and some math, we opted for a 5000 mAh power bank to feed the servants and a 9-volt battery to power the Arduino. Even though it only supports 5 volts, it has a built-in voltage regulator. The spiders were printed in 2 3D printers, XYZ Aware for Pro and Creality. We used 4 red ABS reels until we had all the desired parts. The project on which we based used Nano Arduino, but we used Arduino Uno due to the lack of Nano Arduinos in the market. This led us to have to adapt the spider to the things that were available to us. We had to redraw almost all the pieces, so we had major changes in the shape and geometry of the spider. We used 12 SG97, 3 for each one of the 4 legs. We are aware that we could have opted for more complex servants, but this would lead to even greater change in the spider geometry. In one of the spiders, we have installed a SparkFun ZX distance and gesture sensor. It's a touchless sensor capable of identifying simple gestures. Distance can be recognized from up to about 30 centimeters. The location of the object from the side to side across the sensor is recognized from about 50 centimeters span. The ZX sensor works by bouncing infrared beams of light from the 2 LEDs on either side of an object above the center. We programmed the Spider-Man using a state machine encompassing. Has 3 states, 0, 1 and 2. The 0 state identifies that the dance has to be performed. The state 1 identifies that the dance has been performed and will pass to the free mode. Finally, the state 2 has been created for the robot to stop. The spider was programmed based on the Servo H and FlexTimer 2H libraries and adapting the code developed by Regis available on the web. On the spider with the gesture sensor, it was used the library provided by the manufacturer SparkFun XX sensor. The biggest difficulties were in the process of building the spider. The 3D printer did not give us the piece exactly as we designed them. So after printing, we had to sand all the pieces manually to refract the friction and add grease. After they were assembled, we had to calibrate the servants. We had to come up with a 0 point where the rotation starts so that everyone is in line. We ran the program with all the poles at 90 degrees. This was a very critical step in robot button roll 1, and given that he used engines without encoders, the friction was the biggest challenge. And the use of power banks on all robots led to mass center changes, which also led to changes in programming.